In this video, we'll calculate the molarity of a solution. In this example, we want to calculate the molarity of the solution when there are 4.46 grams of sodium chloride and the solution volume is 250 milliliters. To calculate the molarity, we want to know the mole of solute. In this case, the solute is the compound that dissolves in solution, and the solute is sodium chloride. And we want to know how many moles of sodium chloride are in the volume of the solution. So we want the moles of sodium chloride per liter of solution. So what we know is we have 4.46 grams of the sodium chloride. And what we want to do first is go ahead and convert the grams of sodium chloride into the mole of sodium chloride. So we convert to moles. We want to cancel the unit of grams. So the gram of sodium chloride goes in the denominator. Remember what this is called, the relationship of grams and moles is called the molar mass. So 1 mole of sodium chloride is 58.44 grams of sodium chloride. So 4.46 divided by 58.44 . 0.0763 moles of sodium chloride. So we know the moles of sodium chloride present in solution. We need to divide this by the volume in liters. Now be careful, here we've got 250 milliliters. So what we'll have to do is convert the 250 milliliter into liters. So set up your dimensional analysis. Milliliters get converted to liters. We want to cancel milliliters, so that goes in the denominator. This conversion, 1 liter is equal to 1,000 milliliters. So 250 milliliters is the same thing as 0.250 liters. So now let's put it together. What's the molarity of the solute? So the molarity is the mole of solute divided by liters of solution. Make sure you check the units. Moles per liter, that's the same thing as a molarity. Our molarity is 0.305 molar, or big M, sodium chloride. So in this video, we're going to calculate the concentration, or molarity, of all the ions present when 4.36 grams of sodium chromate is dissolved in enough water to make a 640 milliliter solution. Sodium chromate is a strong electrolyte, so what that means is that we expect 100% dissociation or complete dissociation. Now, a little bit different than what we've done before. Here we want to calculate the concentration of just the ions, not the compound. So remember, molarity is defined as the moles of solute per liter of solution. But Here, we're looking for the moles of the ions, not the moles of the whole compound. So here's what we're going to do. We're going to take our 4.36 grams of the sodium chromate and convert to moles first. Cancel the grams of the sodium chromate, so the grams of sodium chromate go in the denominator. Now, the molar mass here, grams per mole, 1 mole of sodium chromate is 161.98 grams. And so what we've done here is convert to the moles of the sodium chromate. Okay, now that we have the moles of the sodium chromate, now we can go look for the moles of the ions that are present. So we start with our moles of compound. And what we're going to do is go find the moles of the ions present. Let's start with the first ion, the cation sodium. So let's convert to moles of sodium, Na+. Let's cancel the mole of the Na2CrO4. Remember these mole-to-mole relationships. You've got the compound, and here we're studying what's inside the compound. So if you look at the compound, we'll notice that for every 1 mole of the compound, there are 2 times as much sodium. So we're going to double the moles of the compound. So now we have the moles of sodium. Let's do the same thing for the chromate. Let's convert to the moles of chromate, and let's cancel the mole of the sodium chromate. Again, when you see this mole-to-mole relationship, you'll see that for every 1 mole of the compound, there's 1 mole of the chromate. Okay, so we have the moles of the species. Let's get that volume. Now, again, be careful. We have 640 milliliters, but we're going to convert that to liters because by definition, our molarity is the mole per liter. Whoops, sorry about that. That's liters. Okay, so now we can go ahead and go get our answers. So the molarity of our sodium ion is the mole of the sodium ion divided by the volume of the solution. Check those units. Mole per liter for sodium. And we'll do the same thing for the chromate. Now the chromate, remember we had a different answer for our moles. So there we go. Let's do a quick recap. So we're looking for the concentration of all the ions in solution. That means we're looking for the molarity of those ions. Molarity is defined as the moles per liter. So we needed to find the moles of the ions first. That's what we do right here, by finding the moles of the compound first, and then finding the moles of the ions. We converted our volume to liters, and then we found the molarity of each ion by taking the moles of ion and dividing by the volume of the solution. So what we'll do here is we'll find the number of moles present in a solution. Then I'll give you another example where we find the number of grams of solute present in solution. So in the first example, notice that we have a 125.0 milliliter solution. The concentration is given to us 0.255 molar. And this is a solution of KOH, or potassium hydroxide. The question is to calculate the moles of potassium hydroxide present. Now, remember, we're studying molarity. Molarity is the mole of solute per liter of solution. And in this example, we're looking for the moles of KOH. Now notice, the molarity is given to us, and the volume is given to us. And so what we'll have to do is go find the moles using the volume and the molarity. So this is the way we'll set it up. We have 125 milliliters of solution. We're going to have to use this ratio, the mole to liter ratio, the molarity, to convert the volume to the number of moles. In order to use that, of course, we'll have to convert that milliliter unit to liters first. Now that we're in units of liters, the milliliters will cancel. We can convert the volume to the mole of solute, and we can cancel liters of solution. Now, notice what we did here. By setting up the units, converting from liters to moles, canceling liters, notice that mole over liter, well, that's the same thing as the molarity, right? So according to the problem, there are 0.255 moles of KOH for every liter, and liters cancel. And so notice we've done it. We've converted the volume to the number of moles, and our answer here to 4 significant figures. I'll go ahead and answer to 3 significant figures, 0.0319 mole of KOH. So let's take that same concept and let's answer a little bit different question. So in this example, we have 250.0 milliliters of a 0.175 molar solution of silver nitrate. Calculate the amount of grams of silver nitrate present in the solution. So we're looking for the grams of the silver nitrate. The information given to us is the volume of the solution and the molarity of the solution. So if you think about it, we can use the volume and the molarity to find the moles of the solute present. And like we've done before, we can convert the moles of solute into grams by using the molar mass. So let's start here. Let's convert the volume to the number of moles of solute. We do that by using the molarity. In order to use the molarity, we'll have to convert the milliliters into liters. From units of liters, now we can convert to the mole of the silver nitrate and cancel the liters. So again, notice the relationship, the mole per liter. This is the same thing as the molarity. .175 moles per liter. So we've done it. We've converted to the amount of solute in terms of moles. But the question is asking for the grams of the solute present. So once we have moles, let's do something that we've done before. Let's convert the moles of the silver nitrate to the grams of the silver nitrate. We'll cancel mole of silver nitrate and put that in the denominator. Grams and moles, of course, is the molar mass. 1 mole of compound is equal to 169.88 grams. Okay, check the units. You notice you've got the milliliter over milliliter, liter over liter, mole of compound over mole of compound. So everything cancels except for what we want to cancel, or what we want in the end, the grams of the silver nitrate. So the answer here, 7. In this video, we'll talk about dilution. Usually in a chemistry lab, our solutions will be concentrated. What that means is they come in this stock solution of some concentrated molarity or some high molarity. And when you need to use some solution, we'll dilute it to the molarity that we want for the experiment that we're doing. In this example, you'll notice that concentrated hydrochloric acid comes with an approximate molar concentration of about 12.1 molar. So that's a pretty high concentration. Let's do an example where we're instructed to prepare 350 milliliters of a 0.975 molar hydrochloric acid solution. So notice that we're taking the concentrated solution and we need to water it down, so to speak, or create a more dilute solution so that we can use for our experiment. Notice the question is asking us to explain how we would prepare that solution. So a couple of key things before we get started. Notice how we're being asked to prepare a new solution. How do we know it's new? Notice how the molarities are changing. And so keep that in mind as we move forward in this class. We'll be noticing that changes might be happening. So here's one example. The molarity is changing and we're asked to prepare something. So this is an indication that we're going to use our dilution equation. M1 times V1 is equal to M2 times V2. And so the important thing here is that if we know an initial molarity and an initial volume, we can always change the volume to what we want and get the concentration that we want. So what's happening here is we're instructed to prepare. So this is going to be our new solution. So the 350 mLs is going to be our V2. The 0.975 molar HCl will be our M2. And notice that our initial concentration is given to us. Our M1 is going to be our 12.1 molar. So how would we prepare this solution? Well, first thing is, let's go find our initial volume. How much volume of that 12.1 molar solution are we going to need? So a little bit of algebra here. Let's look for V1. That means we have to divide both sides by M1. So M1s will cancel on this side. And so here's our equation. So let's plug this in. M2 times V2 divided by M1. Okay, so right here you'll notice molar over molar, so those units will cancel. Because those molarities cancel, and because here in this dilution equation, we're not changing the number of moles present. I mean, if you think about it, if we have a concentrated solution and then we just change the volume by adding water, you'll notice that the number of moles never change. So we don't have to worry about changing units here, or we don't have to worry about changing units with the volume. So milliliters, we'll go ahead and leave it like that. So when we plug and chug here, our V1 is 28.2 milliliters. Okay, so what does that mean? This means that from our initial concentration, our initial solution, the 12.1 molar, we're going to take out 28.2 milliliters. And this is our original HCl solution. And we're going to add some water, or actually we're going to add this to some water to make a new solution. And then we're going to keep adding water until we get to a final volume of 350 milliliters. Remember, we're not going to add 350 milliliters of water. We're going to add water to get to the final volume because that's our V2. And so that's a common mistake students will make. 350 mLs is the final volume. So how much water do we add? 321.8 milliliters of added water. And of course, that will give us our final volume of 350.0 milliliters.